series circuit, or has she talked about it yet?
It's
Did I say anything? She hasn't talked about it for you guys? No? Okay. So a series circuit. I'm going to draw one for you. This is what one looks like. A series circuit. To identify a series circuit, it has one path for the current to flow through. Okay, so we've talked about current, you know that's the flow of electrons, right? So in a series circuit, it only has one path. So the way to obviously get that, if you take your finger, you go from the power source. This is what we call a schematic. These two lines right here represents your battery or your power source, and these squiggy lines right here represents a resistor. A resistor could be anything from a light bulb to a switch, projector, things like that. That's a resistor. So what?
Or a resistor. Like an actual resistor.
Or a resistor, okay? Okay? So for series circuit, again, there's only one path for the current to flow through. What do you think the resistors do in a series circuit? They slow it down, okay? And the more resistors I add to this circuit, what happens to that current flow? It keeps slowing down. So, when we're talking about a series circuit, again, it's one path for the current to flow through. Each resistor is going to slow down that speed of the current even more, right? So if you're looking at your worksheet right here, easy, you guys probably filled it out. The movement of the charge is called what? Current. Okay? A blank is a complete path for current to flow. Circuit. Any questions on that? Okay. Now, what are the two types of circuits? Well, we just said series, right? And parallel. I'm going to draw a parallel for you, and we'll talk about that in a later day. So this is a series. A parallel has how many paths for current to flow? More than one. Okay, other classes they say two. No, a parallel circuit has more than one path. Okay, and if you're trying to be some sort of electrical engineer like I used to be, or work with schematic drawings, you'll realize that it's not just two. Okay, so this will be a parallel circuit. That will be a series circuit. Really easy. Okay, any questions? All right, I'm gonna erase that. Nobody get confused. All right, and a blank is a diagram, uses symbols to represent. What is that? Schematic. Any questions? All right.
How do you spell schematic?
There's a word bank right there. Any questions? Everyone's good so far. It's really simple. All right, so as you move it down, it tells you to draw a schematic, and I'm going to skip that right now. I want you guys to do that in your own time. But what we're going to talk about now is how to find, or how to do all the math inside that series circuit to find your total voltage, your total resistance, your total current, okay? So if you're looking at the, what says circuit 2, okay? Right here we have 12 volts. What's resistor 1? 10?
Yes.
Resistor 2, 20?
Yes.
10? Oh, they're all 10? Okay. Okay. Real quick. Ohms. All right, yeah, I was about to ask that. Do y'all know what this omega symbol means? It means ohms. This is what you're going to use to identify resistance. Okay? What is current? Anybody know? All right, don't ask questions. I equals current. You may also see that as a letter A. It all just depends, it all depends. But I is current. And hopefully you figure this one out. What is V?
Voltage.
Voltage. It's always going to tell you your voltage. Any questions? All right, in a series circuit, you do have some math to do. It's not hard math. It's really like basic algebra. You're going to use a formula that we call Ohm's law. Does anybody know what that is? Good. So Ohm's law. I'm going to draw this triangle. voltage equals current times resistance. Voltage equals current times resistance. You're going to use this to try to find any information that you need in that circuit. So, in the series circuit, there's some things, some hard, fast rules that will never change. And this is how I always teach you. In the series circuit, your current will always stay the same. So if I find a current anywhere on this circuit, it's going to be the same everywhere on this circuit. Okay? Remember that.
So
Second,
all four sides.
all four sides in a series circuit will have the same current. Okay? Total resistance. How would I find total resistance? Really simple. Get it only in a series circuit. Everything I'm talking about is in a series circuit. So to find my total resistance or my equivalent resistance, I'm going to add up all the resistors in the circuit. Boom, boom, boom. Okay? Add up all the resistors in the circuit. So my total resistance or my REQ or equivalent resistance will be what in this case?
30.
30 what? 30 ohms. I'm good with that. I already was given my total voltage. So I'm gonna just write VT right here. Now I kind of went ahead. When you're thinking about a circuit, this is how I remember it. Think of it as different sections. Section here, section here, section here, section here. If you have two numbers in your section, you should be able to do the math to find what's missing. That make sense? Two numbers in your section, you should be able to do the math to find what's missing. It's okay if I get rid of this? Alright. So I always think of it like this. Where the power source is, think of that as your total size, okay? This is where your total everything is going to be. My total voltage, my total current, my total resistance. At each resistor in the circuit, obviously you can see it's resistor 1, 2, 3, right? Also, there's going to be voltage 1, current 1, voltage 2, current 2, everybody got it? Okay, really simple. If you think about it like that, different sections, and you label it that way, it'll make it so much easier. All right, so let's go back to where we left off. We just found the total resistance, yes? What do we have to find? Well, if you have two numbers in a section, I have two numbers here, 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 again, I'm able to find what's missing. Do I have two numbers in this section?
Yeah.
I have a 12 and a 30, right? According to this formula, since I have a voltage and a resistor, I should be able to find the what? The current, okay? So what math do I have to do? Divide voltage divided by resistance. Now, I don't know how math teach you, but I know some students. Oh, divide 30 by 12. No, don't do that. It's wrong. Do the formula. Voltage divided by resistance. So what is 12 divided by 30? 2/5. Give me a whole number. So my current will be 0.4 what? We didn't tell you it's amps.
What is that?
Amps. Like I said, you might see that current also with an A by it, okay? But it's 0.4 amps. So again, my total side, total 12 volts, 0.4 amps, and 30 ohms. All right, so now we just found my total side. What did we say is the hard fast rule in the series circuit? What never changes? The voltage, the current, the current. Okay? So if I found the current here, I found it everywhere. So what's current 1? 0.4. Current 2. Current 3. Everyone good with that? All right, remember what I said, if you have two numbers in the section, I should be able to find what's missing. Just as I have a 0.4 and a 10 here, and an I and an R, what math do I have to do to find the voltage? Multiply. So what you get for voltage 1?
4.
Voltage 2. Voltage 3.
So once you found one side, you found all the sides?
For what?
Oh, just for the current?
Now, I'm going to say this. This circuit plays out perfect, evenly, because all of our resistors are the same. Like 100% of the time, it won't play out that way. Again, this projector has a different type of resistance than the light bulb. All right, so if you ever do have to write a schematic or you're doing any kind of electrical, it's never going to play out this perfect. But in this case, it does. So don't just say, oh man, it's 4 here, and it's everywhere voltage. It's not always the case, okay? So, we just found our voltage, boom, 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 all 3 sides. Now how can I check my work and see if it's right?
Yeah.
Well, for voltage, what do you say?
It adds up to the.
If the voltages add up to equal my total voltage, you're good. Okay? Now, if you do add your voltages and it's a bigger number than this, you just blew something up. All right? So we gave a quiz on this, and you probably have one later. Someone found a voltage 1 on a quiz for like 500. Whoa, that's crazy. And then they kept going. Okay? If one of your voltages in a series circuit is bigger than the total, it's wrong. Then go back and check your math. You probably did big number divided by little number, okay? So make sure you check that work. Any questions? Simple enough? It's really not that hard. All right, I didn't give you all the blanks, but what I want you to do, turn it to the back and try to do circuit 3. So potential drop, I say voltage 1, 2, 3, but it's the same thing. It's the same potential drop package.
So just like
So we'll have 3 answers.
Yes, you'll have 3 separate answers. You'll have 3 separate answers for number 4, guys.
So what's your total voltage minus your?
So your total voltage is
The
one
voltage you
number.
get first.
Your potential drops on your voltage 1, 2, 3.
Okay.
That's right.
So what would this
What's that?
this classify as?
What?
Like these, like I found
Your eye.
yeah, the amps.
All right, so you can just make voltage.
So
It should be.
it's like this, like
Oh, perfect.
it's almost like
That's your total voltage. So your
Oh, so
total
it'd be
voltage.
one.
So what you're gonna do is, did you find your total resistance?
Yeah, resistance is something like oh, you add
So resistance 7.
it's on the voltage of each of these points.
Okay, once you find your total resistance, that's why I do it like I always draw out everything. Because if you find your total resistance, you
I know, but
find
these are
so right now you just use the same volts. So it's wrong.
so it's individual.
It's everything is separate. That's why I said earlier, I was like, imagine as if it's all different individual sections, right? Once you find one section, you should be able to find the rest of the section. So right now, you just took something out of the total section, right? And try to use it here.
Separate.
So find the total resistance first. Do the math. So 3 divided by the total resistance. That's find the current. When you find the current, then you plug that in. Then when you have the current and the resistance, so now you can find the voltage.
Oh, okay, so we don't. And for this one, is what I did.
Math never changes. It'll be, this case it'll be positive. But you look at it here.
They're like two
Nah, it's more because the batteries on the schematic can look different. They can look many different ways. I always draw it like this because that's what I'm used to. Sometimes it's 1, 2, 3. Sometimes it's like this. So really just preference of the engineer or the simple that you do.
No.
It's always simple. It's always simple. But once we start talking about parallel circuit, I want to tell you, coming out of the battery,
Voltage is like water.
coming out of the battery is always going to be
In the
coming into the battery is parallel circuit and some other things. So if I go out of the battery right here, let's total current. It's like the junction, our current will split, right? Then it comes back together. It splits.
So you mean like
In series, the current is the same everything. It's all different. That important? Make sense though, folks? Not too difficult, not too hard. Yes, go ahead.
Oh wait, so potential drop.
Potential drop.
You get numbers for the answer, right?
It's these numbers.
Okay.
Potential drop at each resistor, or I like to say the voltage. Makes sense. Anybody wants to come do this last one for me? You can do it if you want to. Yeah.
Yeah.
Who wants to do it?
Deja?
Deja?
I do. Deja does.
All right, come on. I do, or whoever. Deja.
Can we just take turns?
Yeah, take turns. Take turns. Yeah. I'll just hold it like this. What are we drawing here? Schematic.
We're drawing a schematic.
Oh, what?
Schematic.
Schematic. I just did it.
Okay.
Alright, now. Alright. Yeah.
Total voltage.
And then total voltage is 9.
All right. It's all yours.
Okay. So we have our total voltage. We have our total voltage, and then to find the total resistance.
All right, equivalent resistance or the total resistance?
Equivalent resistance. We add it all together, and we're going to get 450.
Okay.
And it's simple that the A, the
Oh, resistance.
oh, true relation. I did it right.
Ohms.
And then now we just need this.
It's on the board.
Right. So we just, since we have these two, we're going to divide it, and then what's the number that we get? Somebody give me the number.
0.02.
0.02. And this.
There we go.
And then, so this is the same for every single one. So we're just going to write 0.02. 0.02. Oh. Alright, and then since we have two of these, now we just need to find the voltage. So 1, 2, 3. And now we just multiply these two together, and for this one, we get, what's the number? I forgot. Oh, okay.
2, 6, and 1.
Yeah. 2, 6, and 1. And to check our work, we added all of these together, and we get 9. Woo!
Yay. What? Volts.
Volts.
Remember, don't forget your units, okay?
Yeah.
Because other classes, we probably not checking too much on the units. That Miss Ballard might. I know I do.
I know it.
So make sure you got your right units everywhere they need to be, okay? Is everyone good? This is not too hard. You master series, then you don't have to think about it when you do parallel. Okay? Parallel, starting out there again, is different math. Some of the rules will change. But just remember those things we talked about. Series circuit, what stays the same?
Are you gonna teach it current?
Current stays the same. Question?
Are you gonna teach it current?
Maybe, I don't know. I teach it weird.
Teachers for the rest of the.
So series circuit, the current stays the same. What do the voltages have to do to give you your total?
Add up together.
Voltages have to add up to equal your total. What about the resistance?
They have to add up to equal.
The same, okay? The resistance and the voltages have to add up to equal my total. Okay, the current will always stay the same, it will never change. Only in what kind of circuit? Series circuit. Any questions?
No questions at all? Great job.
Yeah. I actually like this, so that's